Next up, we have Veera from the UCSF, who is going to share with you how they are using dynamic DataWeave to provide secure access to the UCSF EHR data. Veera, take it away.
Thank you, Sabrina, for giving us an opportunity to present at Meetup. Good afternoon, good morning, good evening, depending on which part of the world you are from. My name is Veera Gopalakrishnan. I'm a MuleSoft developer at the University of California, San Francisco. My colleague, Mr. Sony Ranjitkar, is supposed to join me today, but unfortunately, he cannot make it. And thank you, Sony, for helping me to put together this presentation. Today, we are going to discuss how we use the DataWeave scripts at UCSF to add more security to the EHR data access through APIs. So the agenda for today's presentation is first we go over the goals and the frameworks for the EHR industry. And the standards and framework widely used in the EHR industry, and the proxies we developed at UCSF, and some of the projects that are using these proxies, and what challenges we faced when we implemented this proxy and data access security rules at UCSF, and how we externalized the DataWeave scripts and we stored it in the Salesforce custom metadata table, and what are the benefits, and we have a quick demo at the end. If you have any questions during this presentation, you can always ask in the live chat on the right side. We are going to discuss our goals and the regulations that motivated the healthcare organizations to adopt EHR technology. Health Information Technology for Economic and Clinical Act passed in 2009, and this act was passed as part of the American Recovery and Reinvestment Act. They included incentives for organizations who demonstrate the meaningful use of certified EHR technology. And this was led by CMS, Center for Medicaid and Medicare Services. A meaningful use primary objective was to improve the quality, safety, efficiency of the healthcare data, and also promote the interoperability of the data across organizations and involve the patient and their families in their health. A meaningful use was implemented in three different stages. Stage one was focusing on promoting the adoption of EHR technology and data gathering that laid the foundation for the electronic capture of clinical data. Stage two was focusing on more on emphasizing on the clinic care process improvement and also exchange of patient information in a well-structured format. And stage three was focusing on improving the healthcare outcomes. And the objectives are making the healthcare data easily accessible for patient, and also the data easily interoperable across the different hospitals. So when the patient go from one hospital to another hospital, they don't have to repeat the same test again and again. So this help us the patients to cut down the cost and also time, and also it increases the utilization of the healthcare data that we capture using the EHR system. So the standards and framework. There are standards widely used that are developed by HL7 organization, and the leaders from different healthcare industries, they all join together and come up with HL7 standards. The HL7 version 2 was widely used across many hospitals. But the problem with HL7 version 2 is that it's all pipe delimited and very difficult for any new developers to understand the structure. Unless you work on the healthcare industry for many years, and it's easier for you to understand what the data means. It's very difficult for new developers to understand. And the HL7 version 3 was XML based, and when the SOAP web services was getting popular, they came up with this XML version of HL7 version 2. But then the hospitals were not widely adopted to HL1 version 3 because it didn't add much value. And then like the REST API get popular, and all the new developers started using REST APIs. So then HL1 organization came up with a FHIR data model, fast healthcare interoperability resources. This is based on the REST resource model. They divided the data model into like different resources like patient resource, provider resource, allergy resources, lab results resources. So it's very easy for to develop a REST API and using this FHIR model. And then the framework, like it's always challenging to integrate any third party application within any EHR system. So they come up with a stand framework called Smart on Fire. It's a substitutable medical application and reusable technology. The Smart on Fire really helped to integrate the third party application within the EHR system. So the providers, the doctors can choose their own, like the app they like, which will help them when they make a clinical decision. So that can be easily integrated with the EHR system, and then they can use it at the point of care to make the well-informed clinical decisions. So then the EHR vendors started developing these APIs, and when we start looking at those APIs, we come across some limitations. Because like at UCSF, we use the EHR system to store patients from other affiliated hospitals, and we don't want to expose those patient data through the EHR APIs. We want to expose only the UCSF patient data. So that kind of we want to add additional security on top of what the EHR vendor provided. So we have to come up with a process and logic to filter those non-UCSF patients through the APIs. And also the vendor APIs, they developed a lot of older APIs over a long period of time, and it was developed for by different developers. So they haven't really don't follow any standards when we want to use their older APIs. So we have to account for those older APIs as well and add more security to those old APIs. And also the vendors, they came up with their own registration portal for the app that want to use those APIs. They have to first register in their app registration portal, which kind of added challenges to us because we want to use the Mule API manager, but somehow you need to come up with a process to sync the client IDs from the EHR app registration portal to the Mule API manager. And also the URL for the resources, it's all fixed. We don't have flexibility to change it. Only part we can change is the base URL. So that kind of added a more challenge for us. So the proxies we developed at UCSF, we developed three different proxies for exposing the HR APIs. One for FHIR, the other one is for the non-FHIR APIs, and the third one is the custom APIs that we built at UCSF to expose the EHR data. So whatever is not available in the vendor provided APIs, we develop our own custom APIs. So these APIs are developed on the Mule platform, and we added all the needed security for our organization in the proxy flows. So here are some projects that are using the proxies. We can go over the three different flavor of applications that are using these proxies. The first one is a newborn weight application. It's a smart on fire app. It's used by the providers from the pediatrics department. When they launch this application from EHR system, the call goes to the newborn weight app, and then it goes and gets the patient related data like birth weight and the delivery method, all those data related to the baby. It's pulled through the APIs. Then it renders a growth chart to the provider on the EHR system so they can see the growth chart of the baby and then make the decision and see how the baby's growth and whether they need to take any treatment. It's all like informed decision that provider can make at the point of care. So this is a smart on fire app launched from the EHR system. And the next one is the Luma app. This is a patient self-scheduling app. Like the patient upcoming appointments are sent to the Luma app. Then the Luma app will send a reminder to the patient, either through email or text message, depending on the patient's preference. So once the patients get the reminder, they can either confirm their appointment, or they can cancel it, or they can reschedule it. So based on their decision, then the Luma gets the patient's decision about that upcoming appointment. Then it will call the backend APIs through the Mule proxy, and then it will confirm or cancel or reschedule the appointment. This is a patient-facing app. Then the third app is used by the researchers, the Eureka app. Whenever the patient signed up for the research studies, the Eureka app get the data from the EHR through the APIs about their history, their lab results, so that the researchers, the principal investigators, can look at the patient data and understand how their progress through the research studies. So these are the three different applications that are using our current Mule API proxies. But there are many, but I thought these three are three different flavors of the application. So, what are the challenges we faced when we first implemented this proxy on the Mule API Manager? When we first developed this proxy, we incorporated all the validation rules, redaction rules within the Mule flow. And also, when we want to add more application who wants to use this application, they come up with a different requirements for the data validation and data redaction. So when we looked at the EHR APIs, they provided very limited scope for doing any data filtering or data validation. So we have to incorporate those logic within the proxy flow. So since we are included in everything within the flow, it became more challenging for us to add any new requirement, to make any changes to the flow itself, as when new application wants to use these APIs. So that kind of made us very limit. Took long time for us to make changes, and also the application who wants to use these APIs were not happy because it's taking more time for us to make any changes. So there are many demand for using these APIs, but there are pain points. They felt like it's taking more time for them to start using these APIs. So that made us to think through this process and come up with an idea that should be faster and easier to maintain. So then we thought about like why can't we extract all those logic data validation rules and data extraction rules into a separate table or file that can help us to easily like make changes. So that's how we ended up in extracting all these dynamic database scripts into a file and store it in an external table. Let's go through this proxy flow. When we get an incoming request for an API, first we check an authorization check. We check if it's an WAUth or basic auth. If it's an WAUth, we get the access token. We don't get the client ID. So we have to call an introspect endpoint to get the client ID from the EHR system so that we can collect all the Mule API analytics in the Mule API Manager. So then we check if it's a basic auth, then we'll move forward and we'll check whether that particular client has got access to that API or not. Then once we validate that, we'll check for any input validation, like whatever the data that the API caller is requesting, whether they have access to that data or not. So then we use the input data validation using the external database scripts or MEL expression. Then then we go through the business rule validations where we check whether that whatever the data that they're requesting belongs to the UCSF patient or not. If it doesn't belong, then we'll say like we'll send back 403. You cannot call the data. Then if they allowed to to get the data for use as a patient, then we have to do additional checking whether that patient is a confidential patient or not. Like if there's a confidential patient, then we have to check whether the user has access to look at the confidential patient data or not. So those are all additional business rules validation that will do in the proxies. After that, we send the call to the EHR API. Once we get the call back, then we do the data redaction. Like we'll filter out any sensitive data in the API response. Then we send the response back to the caller. So let's go over how the externalizing database scripts. Like we extracted those database scripts and we stored that in a custom metadata table in a Salesforce, and that includes the data validation and also help us to have a different kind of requirements for each API client. And also we can redact the sensitive data for a specific client. Like it's very easy for us to maintain and make changes on the fly. And also we read those configurations and we load it in the memory whenever process starts, so we don't have to go and hit the Salesforce every time we get the call, and it improve the performance. And also like we can do the changes in a real time and enable or disable the scripts in real time, and we have the way to refresh the cache whenever we make changes. Here is a sample validation script. The first one is a DataWeave script, sample script. I'm showing a very simple script here, but DataWeave is very powerful. You can do more complex than what I'm showing here. So the first one is we are allowing only the particular client who applied these data validation rules cannot use the extra items or extra extensions. That should be empty when they call this particular API. Similarly, the MEL expressions. So here we are checking whether that the context name is only encounter or patient allowed for this specific client when we apply this validation script. So it's very easy to make to come up with this validation script and load that into custom metadata table in Salesforce. Next is the DataWeave script that we used for redacting a response, API response. This is a referral, like someone if wants to get a patient referral, we'll check whether the referral belongs to any of the departments. The application is looking for referrals only in a specific department. So we have to filter out based on the caller. We have to filter out if the referral belongs to any of these departments. So we have the database script to redact those data. So here is an example of Salesforce custom metadata. We are going to go into the details of how we storing the external database scripts in Salesforce custom metadata. The first one here I'm showing the allowed path for the specific client. We have the client ID also stored in this table and the path information, and also whether the specific path is required a validation. It's a required validation field which is checked. So this particular path API needs a input data validation, and also it requires a response mapping. We have to redact the data when in the API response. So this is a script we store in the custom metadata, and this gets read in the initially when the flow start, and it loads into memory. So this is an example of validation expression. Then we store a validation expression where we can check for the extra items and whether it's a null, or if there's some cases we allowed only a specific items to be requested through the caller. And we can have multiple validation rules for the client. So we can have which go through each one and apply those data validation rules when we check when call comes through the mule flow. So what are the benefits of storing in an external table? As I mentioned, like we had a requirement varying from one client to another client to do the different kind of data validations and data redactions. So it was not easy for us to implement those kind of validations in the raml. So by doing this way, by storing it in an external table, it's very easy for us to make changes to the data validation and redaction rules. So that gives a flexibility for us and also speed up our time to onboard any new applications who wants to use these Mule proxy flows. And also it reduced cost and increase the efficiency of our team, so we can focus on more different kind of work instead of focusing on changing these proxy flows, and also easier for us to maintain. And at the end, like, it made the applications who wants to use this APIs much happier, and they can start using these APIs sooner, and play around with it and explore these APIs much faster. So we are going to show you a quick demo of how we store the database scripts in the custom metadata table, and we'll also show you calling those APIs through Postman call. Here I'm showing the custom metadata table for showing the allowed path information. As you can see here, we have the allowed path for these health stack applications, and it required validations, and it also required a response mapping. And we are redacting the national identifier from the response. The identifier is a social security number, and this is not needed for this application. So we kind of filtering that out in the API response. So here we are showing the Luma Health get patient appointments validation rules. Luma is allowed only to request for items 7300 and 23015. Those are the only two items that Luma Health is allowed. If they try to send a request with a different extra items, then they'll be sent a 403 forbidden, and with an error message that they can call only with the two items 7300 and 23015. So this the postman calls. Quickly, I'll quickly show how this being called. um, First, we are going to look at the Luma application. I'm making a call to Luma app, and this comes back with the result. And there's no national identifier. It's also filter out for Luma applications. So next is the health stack application, where we check for they're allowed to only call with the MRN. If they call with a different type, then they'll get the error message saying they're allowed to call only with the MRN. So here I'm passing with the MRN and MRN information. When the same app calls, send a request, then they get the data back with data, and there's no national identifier that's get filtered out. So say, for example, if you want to filter out the date of birth also for this application, we can easily do that. When I go back to the Salesforce custom metadata, and now we are trying to filter both the national identifier and the date of birth for this health stack application. I made changes in the custom metadata, and I go here and refresh the cache. It may take a little long to refresh the cache. So it's what it's doing is going and reading the custom metadata and loading all those updated information into the cache. It built the cache. Now if I go back and make the same call again, and now the date of birth was removed from the response. So next we'll look at one of the example. As here I'm making a call using the Luma client. We saw like only 7300 and 23015 extra items are allowed for this Luma. But if we try to send a different item, it will say it's only these two items are allowed in extra items. Say, for example, if I change this to 7300, then it creates patient appointments. So as you can see, it's very easy to make any changes to the data, the web scripts in the custom metadata, and we don't have to redeploy the mule flow. Whenever new application wants to use this API, we just make changes in the custom metadata table and refresh the cache. They are set to go. So this kind of helped us to speed up our onboarding process and help the new application who are interested to use these APIs much faster and increase the usage of this Mule API, proxy APIs throughout our organization as more and more researchers and more application wants to use these APIs at UCSF. I hope you enjoyed this presentation, and thank you. If you have any questions, always post it on the live chat. We are here to answer if you have any questions. Thank you.